Hello, I'm Sean, Head of Developer Relations at Expanso, and today we're going to be building a distributed ETL pipeline with Bacalhau and MongoDB. So let's do it. So why are we doing this? Well, modern infrastructure is big and spread out across the world and has tons of different data in lots of different places. We're calling lots of different things. Understanding where that data is, what it contains, and then most importantly, utilizing it in some way, can become a tricky proposition at scale. And there are two main ways to try and tackle this problem. The first approach is to try and aggregate your data. So you can bring all the data you're generating at all the different locations to one central place and then try and process and analyze it there. But that can cost a lot of money and time in terms of bandwidth and storage. And if you're operating on your data as a whole, then it will take longer to generate insights as that data store grows. The second option is to try and process it at the source of its generation, or close to the source of its generation, and then aggregate those results somewhere else for further analysis. And this is where an ETL pipeline can come in handy. You see, ETL stands for extract, transform, and load. Extract is the first part of the process where we extract data in its raw form from one source or another. In our case, we're going to be using a database, MongoDB, running on some cloud instance somewhere in the world. After we run the extract process, the transform step comes next. And this is where we can take the raw data we've extracted and then apply some sort of process to it, be that cleanup, filtering, enriching, or some other process we want to do to it. Finally, you have the load step, and this is where we can load our newly transformed data into a target system somewhere else in the world for further analysis. And this is a nice way to tackle some of the challenges we had with centralizing our data store, but it comes with its own set of challenges. Managing all those different processes in all those different places at scale across your infrastructure can become unwieldy, especially if you have lots of different things you want to process on lots of different kinds of infrastructure. Right, so let's get building. The very first thing we're going to do is we're going to head over to GitHub and we're going to clone the examples repo from the Bacalhau organization. There'll be a link to this page below, but once you're there, we're just going to go to the code button and we can download either HTTPS or over SSH this repo. I'm going to use SSH. So I can copy that, I can head over to terminal, and I can do git clone. And that's going to bring it down. And once we've got that, we can just simply cd into the examples repo. And in the examples repo, we want to go into the case studies and then the MongoDB Atlas repository. And we can see that we have a bunch of different files and folders in there. Yours may be slightly different as we change these things from time to time, but this is the basic structure. And the one that we're interested in right now is the Terraform directory. So we're going to head in there. The very first thing that we need to do is initialize our Terraform project. And what that's going to do is it's just going to grab all of the plugins and bits of code that it needs to deploy infrastructure, the infrastructure we've described in our Terraform script, to, in this case, Google Cloud Platform. So type in Terraform in it, then hit enter. And that's going to run, and it's going to tell us that we're ready to go. Shouldn't take too long at all. Now, when we get to a point that we want to actually interact with these services, it will take a few minutes for these things to spin up. So we're going to do that now. So let's type in the command to get this thing going. We're going to spin it up now so when we're ready when we come back for it. And very simple, Terraform, and then plan. We'll do the flag of out, then plan.out. Then we want to pass a variable file to our Terraform script. Variable file is just a JSON file, which allows us to specify certain things like what we want our services to be called, where we want these things to deploy. It helps Terraform generate the appropriate script for it to then be able to deploy that to the cloud platform that we've chosen. So that should do it. Hit enter, and it's going to run through and generate that for us. It doesn't take hardly any time at all, but what we can do now is we can simply copy the command Terraform apply plan out, run that, and it will start ticking away, building our infrastructure for us. There we go, and we can see that's ticking along. So when we spin up our infrastructure, each instance is going to have a MongoDB Community Edition database running on it, and a bunch of local scripts will be recording the system usage of the CPU, the memory, and highest process usage of that system into that MongoDB instance. We want somewhere to be able to centralize that data later on. We don't want this thing being sent to a central source all the time, because if you have a bunch of servers, you have a bunch of data points, that can get really big, that can get really expensive really, really quickly. So instead, we're going to have all this information being stored locally, and then we're going to create a Bacalhau job later on, which is going to read from that local database on that system, filter it down for the things that we think are important, and then ship them off to Atlas for future analysis and querying. So let's go and create one of those now. If you just head to the MongoDB Atlas page, you can see that we are pretty much good to go. We can just try free or sign in. I'm going to sign in. You can create an account if you don't already. I'm going to use Google. So once we've logged in or created an account with Atlas, it's time to create a deployment. And we can do that through this overview dashboard that we have here. So I'm going to click the create button, and it's going to take us through the options for creating an Atlas database. And we're going to choose M0 because it's free and allows us to experiment and try these things out without having to do a long-term commitment. And we need to just give it a name. I'm going to call it ETL demo. There we go. And we can choose which provider we want this Atlas instance to be deployed in. Now, it's important to note that this isn't our AWS account or your AWS account or Azure account or Google Cloud account. This is Mongo's account. So we're just going to choose a region inside their managed infrastructure where we'd like our instance to be. And I'm going to stick with the default for Ireland West because Ireland is closest to me right now. And once that's going, once it's all selected, I can just click create deployment. And then it's going to take me through to this lovely user creation bit. So it's whitelisted my IP address, which is obfuscated for obvious reasons. And it's going to give me a username and a password. And we're just going to copy those and we're going to put them somewhere else for later. I'm going to keep them off screen, but it's still super handy to have for when we actually connect this later on. And we click create database user. That will get stored inside of our Atlas account. Now we need to choose a connection method. So we're not actually going to use any of these methods to connect to the Atlas database, but we are going to use some of the information in one of these options to connect to it with a Python script running as a Bacalhau job in a little bit on our private cluster on our spun up infrastructure. And we're just going to click Compass. And Compass gives us this wonderful little string down here. I've obfuscated parts of it, of course, because you don't want to use my account, but what you'll have here is in this little bit, you'll have your username and the password that you just created. So copy that whole string and again, save that somewhere for later on. And we can just close this. This is valid now, so we can close that and we're good to go. Now, our database is created, it's sitting there, it's happy. Let's check out what's happening with our Google Cloud Terraform deployments. And here we are. Terraform has spun up a whole bunch of instances for us. Each instance is running MongoDB in a Docker container, and a Bacalhau CLI tool is installed on there as well. So now we have a means to create jobs and pass them throughout the network in this cluster of instances. If you went through the variables section of the GitHub repo before moving on, then you'll notice that Europe West 2A is our bootstrap zone. That is, it is the one that has the Bacalhau orchestrator on it. That's the node that's going to be responsible for dispatching jobs that we decide to create to each compute node or targeted compute nodes, depending on what we want to do, to extract that data that's in those MongoDB databases locally, do some sort of transformation on them, and load them into Atlas later on. In fact, let's copy one of these IP addresses and see what we've got going on in there. So here we have MongoDB Compass. I'm just going to take the IP address that I have for one of my instances, and I'm going to connect to this database. Now, this is just for me and my demo purposes. I've opened up port 27017. When you're running this workshop, that database won't actually be accessible to the public internet. I'm just doing it so I can show you the amount of data that's being generated at these edge locations. So we can come in here, we can look at the CPU memory records, look at the records, and we can see that already it's only been running for a few minutes, and there are over 1,000 records. There'll be even more in a second. That's a lot of information. We need to do something clever about that. We want to trim that down, because if we were to send all of this to our Atlas store, that Atlas store is going to get big, it's going to get expensive really, really quick. So let's do something clever with that. So we head back to terminal and we're going to run our first Bacalhau job. And this Bacalhau job is going to run in the background on the node that we choose, and it's going to query the database every 30 seconds, and it's going to find only the records that have been using more than 50% of the CPU, and it's going to forward those to the Atlas database so we can see which instances have potentially some problems, or which processes are using up more resources than perhaps they should. Of course, this can be anything. This is just a nice, simple example that lets us explore this technology. So it's time to run our Bacalhau job. We're going to set some flags and pass some parameters, which is going to tell our job exactly what it needs to run and be effective. But the first thing we're going to do is go back to terminal. We're going to type in Bacalhau, and then we're going to start passing in some variables and flags to get us where we want to go. The first thing we want to do is use the API host flag, and this is where we put the IP address of our Bacalhau orchestrator, in this case Europe West 6 IP address, because that's where our jobs will be dispatched from to the compute nodes in that private cluster. And if we go back to Google Cloud, we can see that my IP address for that node is here. So I'm going to copy that, I'm going to put that in there. That will connect all the bits up. The next bit that we're going to do is we're going to use a selector to target a specific region. So we can deploy this job to any compute node in our network, but I'm curious to see what's happening in a specific region. I want to know what's happening in US East 1. So I'm going to put selector, I'm going to type region, and then I'm going to type US East 1. Next flag we're going to put in there is we want to give our container full network access. So even though the MongoDB instances, the database on these instances aren't publicly accessible, they won't be for you, we still need to be able to forward the records inside that database off to Atlas. So Bacalhau jobs by default don't have network access. We're giving it full network access in that local environment because it's a trusted execution environment. It lets us access the local records without exposing local records to the world, and lets us forward on those records to Atlas. So -- network equals full. And the last thing that we're going to do is we're going to tell the Bacalhau CLI that we don't want it to wait. So this is going to be a long running job. It's going to run in the background, querying the MongoDB database inside those instances every 30 seconds and filtering down those records to only records where the CPU utilization has been greater than 50%. So we don't want to be just hanging here waiting for that to complete. So we're going to say wait equals false. Now we're at the point we can start thinking about actually specifying the job that we want the Bacalhau cluster to run. And so we're going to use Docker run. This is a nice little abstraction we have in the Bacalhau CLI that allows us to specify containers for deploying on our clusters. And we're going to set some environment variables. The first one's going to be the local connection variable, which tells our script where it can find the local instance, and we're just using a simple local lookup. So 0.0.0.0 with port 27017. The next environment variable is going to be remote_con, and that's going to be telling our container where it should be sending these records. So if you remember earlier, we copied that really helpful string from the MongoDB Atlas dashboard that tells us how to connect to our hosted database. So we're going to copy that, we're going to paste that in. Obviously, I'm going to hide mine from yours. You shouldn't be using mine, you should be using yours. But that will tell our job how to speak to our centralized data source. The next bit that we're going to do is we're going to pass an environment variable called location. And as we said at the start, an ETL pipeline has 3 stages: extract, transform, and load. We want to transform this data a little bit. So each database, each instance doesn't have an awareness of where it is in the world. It's just ticking away, monitoring the system state. We want to transform the records we get from that local database and add a record saying, and you're here in this world. I'm going to run this in US East 1, so I'm going to set it as US East 1, and that will get added to our records when we push them to our centralized data store, so we know from which instances at which points in the world these records have come from. And now we're at the point where we can specify a container image that we want the job to run, and that's going to be just Sean and Tracy /smt mongo ETL, and we're going to use version 0.0.43. and we hit enter, and that will run. And you'll see that we will get back this lovely UID. So that's telling us that the job is now running in the background. We're also going to run that job again in a separate region, so we have some records from different places. And I think we'll run that in Asia Northeast 3. So we're spanning the globe with this infrastructure at this point. Northeast 3. Don't forget to set your location flag and the actual selector, which will send it to that location. Asia Northeast 3. Hit that, and we get another UID. So we'll give those a few seconds to tick on by, and then we can check out what's happening in our centralized data store. So one thing we need to do before we jump over to making Bacalhau jobs and dispatching them on our cluster is we need to open up the MongoDB Atlas database to the public internet so that it can receive the data from our servers. So when we started, our local IP was automatically added to our instance, to our database, but we need to open it up. And you can be specific if you have fixed IPs, or you can go through the Google Cloud dashboard and find those IPs. But we're going to open it up wide for the moment, just so we can get that done quickly. So we're going to go over to network access, and we're going to go to add IP address, and we're just going to allow access from anywhere for now. This isn't best practices, but for the purposes of this demo, this is what we're going to do. We're just going to confirm that, and now we'll be able to dispatch data from our jobs on each of our instances. So let's take a look at the records that we have. We can go back to our Atlas overview, click on database, and then we can browse collections to see what our data looks like. And from the thousands of records we had before, we now have 62. So we've greatly reduced the number of events that are being stored in our central database by, quite a number. And this is just the important things that we want to be able to dive into, analyze, and do something with later on. And we can do queries even on the data that we have in here. Location, for example, if I want to just check all the records for US East 1, I can filter those down too. If I want to look for Asia Northeast 3, we'll notice that I did a typo earlier on, so it's actually North East 3, but you can see that the code has done exactly what we've asked it to. And that's it. An ETL pipeline with Bacalhau and MongoDB Atlas. Thanks for watching. I hope you join us again soon.